The foundation stone of the erstwhile Central Fuel Research Institute was laid on 17 November 1946 in Digwadi by the Honorable Sri C.H. Bhabha, the then Minister of Works, Mines and Power. Initially, the institute functioned in a barrack in the premises of present IIT ISM Dhanbad, with Dr. J.W. Whittaker as its first director. Later, the institute was officially inaugurated at Digwadi on 22nd April 1950 by Dr. Rajendra Prasad in the esteemed presence of Pandit Jawaharlal Nehru, Dr. Shanti Swarup Bhatnagar and Sir C.V. Raman.
The National Fuel Research Institute, the third of a chain of 11 laboratories planned by the Government of India, was declared open by Dr. Rajendra Prasad at Digwadi, 11 miles from the coal mining centre of Dhanbad. With the president was Pandit Nehru. The institute will conduct research into the coal resources of the country.
To provide a complete solution package from exploration to utilization of coal and minerals, the core competencies of Central Fuel Research Institute and Central Mining Research Institute were merged to a new entity named as Central Institute of Mining and Fuel Research, that is CIMFR, on 2nd April 2007. CIMFR Digwadi campus started its R&D journey with basic research in coal sciences and further diversified itself in the areas like coal carbonization, coal preparation, power coal, liquid fuel, coal gasification, coal liquefaction, chemicals from coal and environmental management. The institute's contribution towards coal science is internationally acknowledged as the Indian School of Thought. The present Resource Quality Assessment Division started its journey as Jharia Coal Survey Laboratory. The expertise attained in characterization of coal is being fully utilized for quality evaluation and assessment of coal being supplied to Indian power sector, which in turn has reduced the cost of electricity in the country. Coal Carbonization Division has its footprints in coal utilization by industrial and domestic sectors. Important developments are soft coke ovens, non-recovery coke ovens, including coal and coke dust utilization in form of briquetting and pelletization. Owing to the scarcity of indigenous prime coking coal, the carbonization wing has developed coal stamp charging technology which enabled the use of low-rank coal in coke making. Washing of indigenous coking coal are found to be difficult. Coal Preparation Division contributed significantly in washing of the difficult-to-wash coal. Specific coal washing circuits have been developed and implemented in coal washeries throughout the country. The institute has state-of-the-art coal washing pilot plant, which includes the fine coal treatment plant developed by the institute. Power Coal Division initially focused on investigation on key coal quality parameters that affect combustion efficiency, slagging propensity, and emissions from Indian coal during power generation. In the recent years, it has its stake in the areas like judicious coal blending strategies through pilot plant experimentations, clean coal initiatives, supercritical power generation, migration from UHV to GCV, and preparation of GHG emission inventory for the nation. Coal is an alternative source of hydrocarbon next to petroleum. The institute provided technology for oil agglomeration plant, beta-naphthol, and oil from coal. Based on age-old experience in coal gasification and Fischer-Tropsch synthesis, the institute has developed a pilot-scale fluidized bed gasifier and subsequently a coal-to-liquid pilot plant producing 5 liters of liquid hydrocarbon per day. Environmental Management Division is actively engaged in addressing environmental issues arising out of various industrial uses of the coal. The institute has developed fly ash soil amendment technology and fly ash building bricks technology, which have solved many waste utilization problems of various industries. Presently, the division is extensively engaged in production of potassium fertilizer from fly ash, carbon dioxide sequestration through biological route, and biogasification of coal. Central Mining Research Station was started in a small building in the present flame-proof laboratory of this institute to address safety, health, and efficiency issues of Indian mining industries. The foundation stone of erstwhile CMRS was laid on 10th May 1956 and the technical block started working in January 1960. The main building of the institute became operational on November 1960 with Dr. J.W. Whittaker as its first director. The institute was in a remote place but was located in the heart of mining area, which made it important, and DGCSIR actively participated in strengthening the core activities of this institute. Objectives of the then CMRS was to innovate safe and economically viable technologies, making best use of the available knowledge base, and to transfer the know-how with a focus on coal and non-coal mines, tunnel and cavern projects, environmental management and testing and analysis services. Initially, CMRS remained a testing laboratory for different safety equipments and established different specialized testing facilities in its campus. The mine ventilation experimentations in the laboratory and field provided sound footing for the development of some effective underground environment management techniques like dynamic pressure balancing and chamber method of ventilation to tackle the challenges of the spontaneous heating and active fires of the mines. In addition to safety, these efforts have saved coal from 1,000 crores of rupees by way of controlling concealed and open fires of the coal mines. Measurement of methane in coal mines started since inception of CMRS to ensure safety against gas hazards in coal mining. Later, it was diversified to prepare fugitive methane emission estimates to the atmosphere. Initiatives taken for R&D on coal bed methane and underground coal gasification are comprehensively recognized by the industries. Data on gas content generated by this institute attracted business and investments by all major oil and gas exploration and production companies in the country. Contributions to development of methodology by estimating GHG emission to the atmosphere was recognized internationally by the IPCC, the elite panel which received Nobel Peace Prize in 2007. The first ever carbon footprint studies for coal mining in India was also accomplished by this institute. The open pit mines were previously being designed by simple experiences with overall final slope angle between 40 and 45 degree for the depth of 50 meter to 100 meter. Monitoring of slope stability was used to deploy primitive levels. More than 90% coal is being produced by open cast mines in India. Here, the depth of open pits is increasing day by day, where the design of slope becomes an important parameter. It may be mentioned here that only 1 degree change in the slope angle may save millions of tons of rock excavation. Now a day of open pit mines are being designed with 60-degree overall slope angle for 150 meter depth. The Agucha mine has been designed for depth of up to 420 meter with the help of state-of-the-art modeling techniques. The strata condition is being predicted by equipments like slope stability radar and motorized total station to minimize the mistakes. The rock excavation engineering section has involved in the operation of more than 400 coal and metal mines and more than 20 prestigious hydroelectric projects in India. Extensive study of rock mass responses against the applied amount, nature and pattern of explosives for the rock excavation is proved to be an effective tool for controlled blasting techniques, which are applied for safe and effective excavation of mineral and coal from challenging sites. The requirement of roof support starts immediately after removal of coal mineral resources. Wooden and steel props, cogs and crossbars were the prevailing support till 1980s. CIMFR started field and laboratory investigations and developed rock mass rating, that is RMR, system to estimate rock load for the support design. This opened an avenue for scientific design guidelines for appropriate support like roof bolts and cable bolts, which are proved to be vital for efficiency and safety of underground mining. Today, it can humbly be claimed that each and every coal mine of the country uses CIMFR developed RMR for the support design. The history of CIMFR research activity on mine stowing is as old as 1960, when the scientists of the then CMRS started experimenting with crushed overburden for underground stowing. Later, the plants for high rate of stowing were designed by the institute. R&D to use coal ash as a stowing material started in 1990s, and the developed technology is being successfully used in underground mines. This new avenue of environment-friendly disposal of coal ash has received national award from Ministry of Science and Technology, Ministry of Power and Ministry of Environment, Forest and Climatic Changes. Generally, the mining operation generates huge quantity of water without any productive use. Alone, BCCL discharges about 3 lakh GPM of water. Ironically, in spite of availability of the huge mine water, coal mining areas suffer from acute drinking water shortage. Mine water as such is not usable and it contains unacceptable levels of heavy metals, toxic anions, organic and biological contaminants. CSIR-CIMFR developed a cost-effective technology to reclaim coal mine water from drinking uses with an approximate cost of 15 paisa per liter. Technical limitations in ascertaining barrier thickness between old waterlogged voids and progressing underground mining created disasters like Chasnala inundation in 1975. Now, CIMFR has successfully applied low-frequency, shielded, portable and intrinsically safe ground-penetrating radar of 60-meter range to arrest such possibility by demarcating barrier thickness and delineating abundant mine voids. Technical skill and experience play vital role in an engineering design for understanding rock mass behavior and in situ stress conditions. Geotechnical parameters of both longwall and board and pillar routes of underground coal mining have extensively been studied in laboratory and field. The conceptual idea was first experimented in laboratory and accordingly, equivalent material mine modeling technique was developed by this institute in the 60s for strata control studies in the laboratory. This simulation approach proved to be instrumental in developing different popular mining methods for extraction of thick and difficult coal seams. CIMFR analytical equation to estimate in situ stress has been appreciated worldwide, and a scientist of CSIR-CIMFR was given Rock Mechanics Award by the Society of Mining Engineers, USA. This institute developed a number of empirical formulations like pillar strength equation in 1987, rock mass failure criterion in 1997, and mining-induced stress estimation in 2003. Here, computer simulation was used for parametric investigations. An appropriate combination of different available experiences with results of the various investigative tools provided the design of final snook in mechanized depillering and also in roof bolt-based breaker line support, which have added a new dimension in extraction of coal locked in pillars. Today, CSIR-CIMFR possesses unique knowledge base of rock mass behavior and in situ stress conditions for the optimal design of an underground mining structure. The R&D journey of this institute is full of translational research and has continuously produced high-value inputs for the industry. The trend of external cash flow may probably give an indication of CIMFR growth story in last 73 years. In addition to numerous scientific and technological developments, professional achievements and appreciations from academicians and industry, this institute has often earned various institutional awards, and some of them are the Technology Award 2017 for Business Development and Technology Marketing, Technology Award 2012 for Development of Non-Nitroglycerin Based Explosive, Technology Award 2011 for High Wall Mining, National Fly Ash Award in 2005, NRDC Technology Award in 2003, CSIR Technology Award in 2000, and many more. Thank you.